Okay, so let's look at number 6 from the homework. And I'm going to turn on the straw feature, and hopefully you're not necessarily seeing it on your screen. I'm going to move the window a little bit because I do see it on my screen and it's interfering. Oh, it won't let me. I've got to exit that. Let's see if I can just move the window just a tad. Okay, there we go. Now, like I said, I don't know if you see this little draw thing that I'm using, but all right. So up here, we have a mean of 13.1, a standard deviation of 4.3, and we are told that this is a normally distributed distribution. So let's notice that this says the probability that x is less than 12 as opposed to x bar is less than 12. X bar is less than 12 is going to use the formula that you used on the homework that you sent me. But just x, we want to use our basic z formula, which let's just recall that was x minus mu over the standard deviation. All right, so in our case, our x that we're going to look at is 12. Our mu is 13.1. And then we're going to put that over our standard deviation of 4.3. Now notice sample size does not come into this because this is x. This is a single value rather than a sample size as it tells us in number 9. All right, so if I put this into my calculator, 12 minus 13.1 is negative 1.1. And I want to divide that by the 4.3 on the bottom. And I apologize for my somewhat first grade like handwriting as I write with my mouse. So let's see, divided by 4.3. And that's going to be negative 0.2558. And then we're going to look this up on our chart from there. And I'll leave that part to you because I noticed that you did do it for number 9 and for number 13. So this is that same idea. Now that we've got it, you can go ahead and look it up. The only difference is that you've got to use this formula versus the one that has the square root of n in the bottom of this part right here, which is what you use on number 9 and number 13. Now, number 10 is the same, except after you look it up, you've got to subtract your probability from 1. All right, now let me move on to, I'm going to exit drawing. It'll get rid of this stuff, so then I can move down. Number 18. And number 18, it asks you to do it without without using StatCrunch. You're going to do this discrete probability by hand. So let me pull up a blank Word document. Okay, so in 18, we are dealing with the outcome that we get when we roll a die. All right, so if we think about just a normal 6-sided die, the outcomes we could get would be a 1, 2, 3, 4, 5, and 6. All right, so let me go over to my blank document, and I'm just going to put X, that's my outcomes. And my outcomes could be 1 through 6, so I will put those down. And if it's a fair die, we expect that our outcomes probability are all the same. We would expect that the probability of getting a 1 when we roll the die is 1 out of 6. So let's just 1 out of 6 for every single one of these. We would expect that to be the case as long as it's not been tampered with or anything. So that's the probability distribution, that right there. All of my possible outcomes and their probabilities. Okay, so let's see what B asked for. Let's see. Calculate the mean, and then C is the standard deviation. And then we want to identify the median. This is a uniform distribution, which is also symmetric, so the mean and the median should be the same, essentially. So really, we can say it's the same as B. But let's go ahead and find B and C. All right, so let me go back here. All right, so this is a discrete probability distribution. We know it's discrete because all of our x values are counting numbers. All right, so to find the mean, we need to make a new column, x times p of x, because our formula for the mean is the sum of the x times px's. So we need to do that column that is xpx, and then we'll add them up, and that will be our mean. Now, when I turn off this little draw feature, it's going to disappear on us, but that's okay. All right, so right over here, I'm going to multiply these two columns together. So 1 times a sixth is still a sixth. 2 times a sixth is 2 sixths. Remember, you're just multiplying 2 over 1 times 1 over 6. So the 2 is only multiplying times the top. Now, I could reduce that, but I'm not going to because it's going to make our sum easier if we don't reduce it. 3 times 1 over 6 is 3 sixths. 4 times 1 over 6 is 4 sixths. 5 times 1 over 6 is 5 sixths. And 6 times 1 over 6 is 6 sixths. All right, now let's just add these up. Let's see. 1 plus 2 is 3, plus 3 is 6, 10, 15, 21 over 6. Now, for the sake of my mean, I will go ahead and make that into a decimal, but let's just put our mean is 21 over 6, and I'll just put that into the calculator to make it into decimal form. 21 divided by 6 is 3.5. Okay, so that's our mean. Let's go on to our standard deviation. Now, our variance calculation for a discrete probability distribution is this. And it's the square root, it's the sum of x squared px. Well, trying to write with my mouse is not working out very well, but I think you can make that out. Minus the mean squared. So now, as soon as I go out of the draw feature, this is all going to disappear on us. So I'm going to write down my mean for future reference. It's 3.5, so we can come back to the mean and use it in this formula. But let's notice the first part of this, I need x squared px. So I'm going to make a column for x squared and a column for x squared px, and we're going to do those calculations first. Now, as I said, when I exit drawing, this formula is going to disappear, but we'll still use it. So I'm going to exit drawing, and up here, I'm going to make a new column, one that's x squared, and one that is x squared times p of x. All right, so x squared. I'm just going to square everything that is in the x column. So if I square 1, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And 6 times 6 is 36. All right, now I want to take x squared px. Now we got to be careful that we want to multiply this column times the p of x column. So we got to be careful not to get that one. So 1 times a sixth. Well, that's 1 sixth. 4 times 1 sixth. Well, that's 4 sixths. 9 times 1 sixth. 9 sixths. 16 times a sixth. 16 sixths. 25 times a sixth. 25 sixths. Oops. And then 36 times a sixth. 36 sixths. And then just like we did with the other column that we made back here, let's add these up. So if I add those up, 1 plus 4 plus 9, so let's see, 5 plus 9 plus 16 plus 25 plus 36 is 91/6. Now I'm going to change 91/6 into a decimal. So 91 divided by, oops, except I can't type. 91 divided by 6 is 15.166666. So our variance is going to be that 91/6, which was 15.166666. Let's see how many of those sixes. I've got 6 of them. Seven minus the mean squared, and our mean was 3.5, so we want to square it. All right, so let me do that whole thing in my calculator. So minus 3.5 squared, and I get 2.91666666. So all right, and then to find the standard deviation, I just want to take the square root of the answer that I got for variance. So I want to take the square root of 2.91666667. So square root of that, 2.91666667. And it ends up being 1.7. And I'm not sure how many decimal places I asked to. I know it was 3 or 4. So I'll just go to 4. But of course, if we had to go to 3, this would end up being 1.708. Okay. All right. Uh, so that is the standard deviation, and how do you do that by hand? And then that last question was asking what the median was, and since it's a uniform distribution, we expect the median to be the same as the mean. So we expect it to be 3.5. All right, now let me just answer your last question about number 23. You asked if they were right skewed, and I think I can pull up your homework here. So here's where you did it in StatCrunch, and you had, for a sample size of 1, you had a mean of 1.153, and you had a median of 1.0127. And we can use the general rule that if the mean is bigger than the median, that's pulling everything to the right, making it a right skewed distribution. And as we look at these, we can see that that is, I believe, the case for all of them. 9.4, yeah, and 9.2, yeah, so the mean is bigger, and 9.995. Oh, now here's it. No, it is 0.995. Just read it wrong. And 0.964, still bigger. So all of those are right skewed. Now, if the reverse were true, if the mean were smaller than the median, we'd say it was left skewed. And if they were roughly the same, it's either a uniform distribution or a normal distribution. And we would have to kind of look at the graph to determine, do all of the bars look the same height, which would make it uniform, or does it roughly have that bell-shaped curve, which would make it normal? So I hope that helps you through these.